As you increase the frequency, you increase the strength of that electromagnetic effect. I've got behind me on the board there, ADSL2 sends a signal down your telephone line of up to 2.2 megahertz, double the frequency of FM. The skin effect, if you can remember me talking about skin effect, it's on another video, is the AC current, alternating current, travels mostly around the surface. At 2.2 megahertz, the diameter or the depth of that skin effect, the useful conduction, is around about 0.05 of a millimetre. So if you've got 0.05 of a millimetre both ways, that's a 0.1 millimetre wire, that carries the current. Anything more than that is just a waste of copper. The cable TV, let's have a look at how that works. Here's a bit of a cable. I've just stripped the insulation off the end. Cable TV in Australia works at 600 megahertz. So I've just knocked the camera out. Cable TV in Australia works at 600 megahertz. Here is basically, I've just stripped the insulation off the end of a cable they use for cable TV. In it I've got a few loose reinforcing strands, and I've only got, as you look at it end on, I've only got two cables in that. One is the centre cable. This sheathing around the outside is the second conductor. Why is it circular? Because this central cable, as the current's flowing down it, it's creating a magnetic field that's going that way. The top half sees the magnetic field travelling this way, the bottom half sees it coming back. So that means this changing electrical signal here produces two currents in this outside conductor, or more than two, produces infinite currents that oppose each other and cancel each other out. So let's say the one on the top goes that way, the one on the bottom goes that way, the induced current produced by the changing magnetic field around this central cable. Coax cables are a lot more efficient than ribbon cables at carrying data because it completely eliminates electromagnetic interference. The central cable, as you can see here, I'll hold it up against my finger, is travelling around about 0.8 of a mil. The skin effect of this cable that's working at 600 megahertz for cable TV is about 0.1 of a mil. So that means that that's travelling okay. This central cable is copper-coated steel. The steel gives it tensile strength, the copper coating gives it, the outside copper coating is 0.1, 0.2 millimetres of a thick, so the skin effect at 600 megahertz means the electricity is travelling through pure copper. The steel on the inside of this is giving tensile strength and contributing very little to electrical conductivity. Now, of course, if I peel this back, so there you go. There is one conductor, there's the positive and negative. I've got two conductors on a coax cable. So that is TV cable.